Alright, this is Sparks Pre-Calculus. This is day 18, factoring cubic, quartic, and quintic polynomials. What a cubic means, it means it's a degree 3, that means the highest power of x. This is the third power. Quartic would be degree 4, that would be x to the fourth, and quintic would be x to the fifth, meaning it is a degree 5 polynomial. First thing we need to remember before we can get started with factoring is that everything must be in terms from greatest to least degree. So if we look at this at 1 right here, we see that we have 4x squared minus 25, which is x to the 0, so we have them in descending order. Alright, so we're going to start by the special circumstance with a difference of 2 squares. What we have right here, this is 2x squared, that's a perfect square, minus 5 squared. And this is a special case where the two binomials that multiply together to get 4x squared are called conjugates. And it's 2x, which is the square root of the first perfect square, minus the square root of the second perfect square, and then 2x plus 5. And when you have this case where you have a plus b, it's a conjugate of a minus b. That's what conjugates are. So we have 2x minus 5, 2x plus 5. So we wrote down what the number 1 rule of factoring is. I would say the number 2 rule is that to look to see if there is a greatest common factor, GFC. So to do that, I would multiply this out, expand it. I'm being kind of simple here, but I would expand it because 2x squared is 2 times x, and 8 is 2 times 2 times 2. And from here you can see that they share a common factor of 2. Turns out that the greatest common factor is 2. Now that we've done that, we can see right here where we have another one of those cases of the difference of squares. So we have 2x plus 2, x minus 2. The order of the x plus 2 and x minus 2 doesn't matter. As you can see up here, I put the minus first, but it doesn't matter because we're multiplying. Alright, so we're going to factor 12x minus 3x cubed, and we're going to follow our rules. The first one is to write it in descending order of degree. Second thing, we want to look for common factors. So we have, like this, negative 3 times 1, x plus, I could make that negative 3 times negative 4. I could factor a negative 3 out. Let's see, so negative 3, that's a common factor, as well as one of these x's. So we have negative 3x that comes out, and then we're going to rewrite what's left, x squared minus 4. Oh, and here's the difference of squares. Negative 3x, x minus 2 times x plus 2 would be our completely factored polynomial. Why don't you go ahead and factor 75x minus 3x cubed and check your answer. So pause this right now. You'll see that the final answer is negative 3x times x plus 5 times x minus 5. So we can use the same idea of the difference of squares even if it's a higher power of x. Such in this case, we can rewrite this as x squared minus 2 squared. And we've got these two, so we're going to have x squared plus 2 times x squared minus 2. And since 2 is not a perfect square, we are done with that one. Down here, we'd want to factor that 2 out first. We still have x squared minus 16, which is 4 squared. So we get 2 on the outside, and on the inside we've got x squared plus 4 times x squared minus 4, and we have the difference of squares again. So we have 2 times x squared plus 4 times x plus 2, x minus 2, and this would be the final answer. Go ahead and try this with the next one. Pause it here and check your answer. Alright, this one comes down to 2x times x cubed minus 16. That's not the difference of squares inside there, so we're finished. We don't have anything we can do with x cubed minus 16 this time. Go ahead and give that next one a try and check your answer. So pause this now. And I found the difference of squares hiding in there, so I got 2x times x to the 4th minus 4, which becomes 2x times x squared minus 2 and x squared plus 2. So before we start factoring trinomials, let's go ahead and multiply some binomials, and so we get some more information about them, and then we'll think about working backwards. So if we FOIL this, you probably recall FOIL, first outside, inside, last. We have 3x times x, which is 3x squared. And then outside, so then you've got negative 6x. Inside, negative 4x. And then, excuse me, last, we get positive 8, which we can simplify by adding like terms. 3x squared minus 10x plus 8 would be that completely simplified. Alright, so let's fill in the blanks here. The product of the first terms, well, that was 3x squared. The product of the last terms, that was our 8. The product of the outer terms, that one was our negative 6x. And the product of the middle terms is negative 4x. Alright, we're going to go ahead and do the next one. Go ahead and FOIL this out, fill out the fill in the blank, and check back. So pause this now. Notice how these are fairly similar, and that we just first outside, inside, last, and then simplified by adding like terms. But this one has a 4th degree and a 2nd degree term, where this one up here just has a 2nd degree and a 1st degree term. However, they multiply out just the same. We end up with a trinomial when we're done. We're going to go ahead and write these 3 statements that relate the final answer in each of the examples above to the 4 quantities you were asked to identify. The product of the first terms is the highest powered term in the trinomial. Secondly, the sum of the outer and inner products must be the middle powered term in the trinomial. And lastly, the product of the last terms must be the lowest power term in the trinomial. So what does all of that mean that we just wrote? What that means is when we factor this into 2 binomials, that whatever we get here and here has to multiply together to get 2x to the 4th. And whatever we multiply together to get here and here has to be equal to 20 when we multiply them together. So in order to get 20, there's 1 times 20, and there is 2 times 10, and there is 4 times 5. So we only have 3 choices for that. And because this is positive, we need them both to be positive or both to be negative. And the only way we can get out a negative 13 is if they're both negative. Then we look at the front half, and the only way to get 2x to the 4th, when we have an x squared as our middle term, is going to be 2x squared times x squared. And these are both negative. So then we could guess and check our way by plugging in 1 and 20 into those blank spaces that we have here, and then flip-flop them and do 20 and 1, or we do 2 and 10 and 2, and mentally you need to check it. So if I put, let's put 2 and 10, I would get 2x squared times negative 10, that's negative 20, and I'm going to add to it a negative 2, which is not 13. So I guess I'll check our way through that, and we end up with this one being -4, and this one being -5. There are other methods to this. There's the box and diamond method. If you have good number sense and you know your multiplication tables, factoring doesn't tend to be very difficult. If you want another method, please let me know, and I would love to show you one. But once we get to this point, we're still not done, because this is the difference of squares. So we have 2x squared minus 5, and then we have x plus 2, x minus 2. So really what we're doing is we're factoring just like we normally would, except we have that x to the 4th in there, which changes things. This one is exactly the same way. We know it has to be x squared and x squared. We need two numbers that multiply to get -5 and add together to get 4. So we don't have a leading coefficient except for 1. So that must be, let's see, plus 5 minus 1. That'll work. This right here is the difference of squares. It's kind of hidden in there, but it is the difference of squares. This is x plus 1, x minus 1, and this is still x squared plus 5. I'm betting we're going to need lots of factoring practice that aren't quite at this level before we get to our in-class. Alright, so we're going to do this one. Notice there is an x in every term and a 2 in every term. You could break this down. Of course, we want to wean you away from that. We want you to be able to see this without doing this. But you can see there's a 2x, there's a 2, there's an x, and there's a 2x, which goes out front. What we have left is x to the 4th minus 5x squared plus 4. But of course, we're not done, because this is going to factor. So we still have that 2x. We know it's got to be something like that. X to the 4th, so we have x squared and x squared. We need two numbers that multiply to 4 and add to -5, so that's got to be -4 and -1. And we're still not done, because we have two difference of squares here. So this one becomes x plus 1, x minus 1, and this one is x plus 2, x minus 2. So when we factor these, we could end up with 3 terms, like we did in here, or in this one we end up with 1, 2, 3, 4, 5. I'm going to end this video right here, because the next one is factoring by grouping, and this might be a good place to stop in the effort of not making this video over 24 minutes long. So, pause this and I'm going to end this, and you'll have to come back and watch the rest of day 18. See you soon.